Yesterday, or one day, someday, we were doing this thing called practice, and we didn't quite get through it, but I got through it with the other class, and so I finished it, and there's a video available. So if you want to finish that practice on your own, we're going to look at the other practice today, but if you want to finish that one on your own, that's up to you, perfectly fine. One quick comment I want to just remind you of is, when we are talking about functions being even and odd, remember what that means. If you are an even function, and f of 5 is -7, then f of -5 will also be -7. That's what it means to be even. If you are odd, and f of 5 is -7, then f of -5 would be +7. Even means sign changes on input, don't matter. Odd means sign changes on input, change the output, right? Okay. Now, on that extra, there's a thicker packet I gave you. It just says 8 extra practice 1.4 to 1.6, and it's just a bunch of different worksheets that Mr. Passwater has. I threw them all together here, so we don't have time or energy to do them all, but maybe we'll do one problem from each set and more if we need to. So let's look at, I'm on the very front, okay? And the first 6 problems, it says, figure out if it's a polynomial, and then if it is, indicate the degree. I want you to quickly look through those 6. Tell me which ones are not polynomials. Which ones in the first 6 problems there, which ones are not polynomials? Two is not a polynomial. Why is 2 not a polynomial? Because it's got an exponential inside of it, right? Has an exponential. That means it's going to shoot up into space. It's not a polynomial. Okay, what else did you say? 3 is not a polynomial because what does that middle term really mean? 4 over x squared. And as soon as you put an asymptote in it, which you do when you have an x in the denominator, no, not a polynomial. What kind of exponents do polynomials have to have? Whole numbers, yeah. You gotta be like 1 and 2 and 3. Those are polynomials. Okay, are there any others you said? 5. 5 is actually a polynomial. E is Euler's constant, 2.718, the base of the natural logarithms. So it's just a number, just like pi. So there's no rule that says polynomials have to have rational coefficients. They have to have real coefficients. We don't want any pi's. But no, that's a polynomial. If you graphed number 5 on your calculator, it would be a polynomial shape. Right? In fact, quick review, what would the end behavior be for problem number 5? The end behavior. So, what degree is it? It's 3rd degree and negative. So isn't it going to look like this? So going to the right, we're going down. Remember, this means to the right. And going to the left, we're going up. That's a huge idea in this whole unit, guys. You get that? Good with that? Okay. All right. let's do one more in there. How about 6? 6 is a polynomial. What would be the degree of that polynomial? 5. I've heard 5, 4, and 6. Now I heard another 4. Guys, if you multiplied it all out, what would be the highest power you have? 4. That's a 4th degree polynomial. Now, what would be the leading coefficient on that x to the 4th? -3, which means it would be a down, down. So its end behavior would both be negative infinities. Right? Okay. All right, let's look at the part underneath here. Let's look at number 7. Determine any x values where the graph has a local extrema. Remember, local, relative, those are the same words, and extrema means maxes and mins. Okay, that's just kind of the generic term for maxes and mins. Okay, so for picture 7, determine the x values where we have local extrema. Well, first of all, do we have any? Yeah. Looks like we have a local or relative minimum where x equals 1, and another minimum, where a relative minimum, where x equals 6. And then we actually have a relative maximum where x equals 3. Right? Do I have an absolute, those are local or relative, do I have an absolute maximum in this problem?
No.
Nope, got arrows. Do I have an absolute minimum in this problem?
Yep.
Yes, where x is
6.
Okay. Yeah, then all the rest of those are the same. So what's hard about 8?
It doesn't have.
Okay, that's okay.
Is it just one local max? Or is there?
There's one relative maximum, and that is where x is 7.
What is it? Is 4 anything?
Yeah.
Relative and local mean the same thing. Relative and local mean the same thing, so those two words can be interchangeable. It happens that that is also the absolute, because that's the highest point on the graph.
What is X? This is
There's
4.
no minimums on that.
Like 4 looks like is 4 anything?
4 is a point of inflection.
But it's not like a minimum or
It's not a minimum or maximum, but it is definitely a point of
inflection.
inflection. Because the curve is changing from concave down
Concave
to
up.
concave up
So
at that
if
point.
we have that problem when we get to us, we just leave local minimums out there blank.
Or any.
Yeah, it says if there aren't any, write none. All right, so all those are the same. 13 asks for global min and max. Well, we kind of already talked about that. Does 13 have a global maximum? It does, where x equals 8, and the value is 8, so global minimum is 8, or excuse me, maximum is 8 at x equals 8. Would you agree with that?
Yeah.
And then how about a global minimum?
3 -1 or negative.
3 at -1, so the value of the minimum is 3, and it happens where x is -1. That looks about right. Let's look at the next set. Determine if the given polynomial must have a global min, global max, or neither. Explain your reasoning. All right, let's look at number 17. So think about what that looks like, guys. What does 17 look like? Just in general. It starts down and ends down. Now think about that. We have no idea right now exactly what it looks like. But if it starts down, does whatever it does, and ends down, what does it absolutely have to have? It has to have a global max, because if it has to go up and turn around and come down, doesn't it have to have a highest point in there somewhere? We don't know where it is, but it has to have a global max. Now, what about 16? 16 doesn't have either one, because why? It's odd degree. And what do odd degrees do? One is up and one is down. So isn't that picture gonna have arrows? I mean, this one has arrows on both ends, but they're pointing in the same direction. And odd is gonna have one shooting up, so no max, and one shooting down, so no min. Now, could it have a relative max and min in there? Absolutely, but not an absolute.
For the explanation, will you just explain that?
Yep, that would be perfect. Explain the end behaviors. That would make you sound really, really smart. That would be good. All right, let's look at 18. These are the ones that we can sometimes have a conversation about, but to our best of our ability, where does it look like in picture 18, we are switching from concave up to down or vice versa? Where would you say X values? -2, definitely, I would say. Kellen says X equals +1. Could you live with that?
Yeah.
And that would be it, wouldn't it? Just those two? What are points of inflection? Places where we change concavity. Yep. All right, 20. These are sketch your own, so let's have a couple volunteers. We'll do 20 and 21 on the board. So, see if you can come up with a picture. So 20 and 21. Let's see what you can come up with. Yeah, just don't do it. Yeah, that's what I want. I want people to rush up there. The quicker we do it, the more time we have to do more problems. Look at number 20. We're supposed to have 2 points of inflection. So it look like I have one in here somewhere. Would that be a point of inflection? And maybe one here. 2 points of inflection. All right, I'm supposed to have one absolute maximum and no absolute minimum. What do you think? Yep, nailed it. All right, number 21. We have one local maximum, 2 global minima. So these guys are at the same level. So like they're moved down 2 or something, right? And 2 points of inflection. So maybe a point of inflection here and here. What do you think about that? Yeah, yeah. Good job, folks. Awesome. All right, let's see what's on the next page.
Can we do 22? I might be sure.
All right, so let's look at number 24. Maybe we'll do all that. For graph h of x, number 24 says, find the intervals where the rate of change is positive and decreasing. So where is the rate of change positive and decreasing in that picture? Positive and decreasing would be what? What did you say? Negative 1 to 1. I agree with that. Let's talk about that. Why is the rate of change positive from negative 1 to 1? Because the curve is going up. Why is it decreasing? Because it's concave down. Does that happen anywhere else? Is there any other place where we're going up and we're concave down? No, that's the only one. All right, 25. The rate of change is negative and decreasing. So that would be from, well, I wouldn't say 1 to 4. Why not? What's wrong? It's decreasing on 1 to 4. But, I mean, it's negative from 1 to 4. But why can't I say it's decreasing? Because part of it's concave up. So we have to figure out where our point of inflection is going to be. So maybe at 2. Could you live with that? A point of inflection at 2? So we would be negative and decreasing from 1 to 2, basically. Is that it? Yep. All right, now I want it to be positive and increasing. So positive and increasing would be 4 to 7. And negative and increasing would be 2 to 4, if we count 2 as our point of inflection. Is that all right with everybody? All right, let's look down at number 28. Okay, now we have a new graph. Let's just do one of these. What's happening from 8 to 9? Describe the curve. What's happening from 8 to 9? It is negative and decreasing. Because on that portion of the graph, we're going down and we are concave down. All right, use your graphing calculator. Okay, are you guys okay with the graphing calculator finding max and min? You're gonna have to do that tomorrow?
Yes.
Okay, all right, let's go to the next page then, 1.5. Let's go down to, well, let's do the first one first. Make sure, what's the degree of polynomial in number 1? 3. If you multiplied it all out, what do you have x cubed? What are the zeros? Negative 3, multiplicity 2, and 1. Right? So let's get down to a harder one. What about number 8? What's the degree? You can do that. What's the degree? 7. Now to find the zeros, you're going to have to factor, which y'all know how to do that. What'd you come up with for your zeros? 0 with a multiplicity 3, right off the bat, we got that one. And then I got -2, -5, and 4 with a multiplicity 2. Sound good? See some nods, awesome. All right, 9 through 14, simple. What's the conjugate for number 9? Plus 2i. What's the conjugate for number 14? 3i, perfect. 15 says, I have something that has all these zeros. What is the least possible degree of the polynomial? I heard 4 and I heard a 6. Anybody else want to take a stab at it? I think it's 6, because you got 2 3s, all right, so that counts as 2. But what about 3i? It also counts as 2 because you have -3i. And then 4 minus I counts as 2 because you have 4 plus I. So that one would have a minimum degree of 6. Then we have some actually factor problems. I'm not sure what those are doing in there, but let's go down. Let's just take a look at number 20. Well, it's not factorable over the real numbers, but could we actually factor x squared plus 4? Not over the real numbers, but if we were looking for the zeros, wouldn't we set that equal to 0 and solve and get plus or minus 2i? So what could the linear factors be if we were allowed to use imaginary numbers, and polynomials have imaginary roots sometimes? What would these factors be? X plus 2i and x minus 2i? These are called the linear factors, and remember, everything is factorable, but sometimes you have to put in imaginary numbers to do it.
So is this gonna be difficult?
Could.
So,
I mean, we had some stuff in some exercise where we had to find the linear factors.
would it ever be not something?
Nope. Nope.
The 44.
Not if you're allowed to use
You
negative.
do the same thing to x squared plus 9, right?
Yep, that would be x plus 3i, x minus 3i.
Do we have to
So-
show the factor?
Can you,
The question said find the factors.
can you graph it?
Now, can you graph it? Obviously, you can graph it. If you type that into your calculator, you'll get something. Can you plot these zeros? No, because they're imaginary. So you're gonna get some kind of a W shape like this, but it's gonna be all up here. It isn't gonna cross the x-axis at all. So, and you're physically not gonna see the 2i and 3i because we're in real number plane.
How'd you know it's linear?
X, degree 1. So we say find the linear factorization, we need to break it all the way down to x's. Not quadratic factorization, all the way down to x's. All right, here we go. Next worksheet. Determine the degree of each polynomial. Now, it looks like he was kind, because as I'm looking down through 1 through 6, what are my beady little eyes checking right off the bat? What's happening to my x's, right? Right? I don't think, I told you this already, I don't think on the actual exam, on this part I saw, that they're deliberately trying to trick you on that, but you have to be aware the x's have to be the same size intervals. So let's just pick one. How about 5? Can we figure out what's going on in 5? cubic, I heard cube. They all think it's cubic. Olivia's flashing 4 fingers back there. That's what all these guys got 4. Let's look at the first set of differences. Did you mean 4?
Sure.
You're sure you did? Mean 4? So the first set of differences didn't match. The second set didn't match. The third set didn't match, but the fourth set did. So it's quadratic. It would be a 4th degree polynomial. All right, is that okay with everybody? Be careful when you're finding your differences. Get your signs right. So from -7 to -5 is +2, but from -5 to -7 is -2. So make sure you're going in the right direction. All right, 7 looks like a fascinating problem. G is an odd function that is strictly increasing. Okay, what does strictly increasing mean? Do you know? It means that the y's are all going up, okay? On this particular thing here. All right, find the values of A, B, and C. All right, so we know it's an odd function. All right, tell me what you think. A's, B's, A plus B's and C's, okay. What do you think? Do you notice anything? Alex?
It's B4.
Is B4. Well,
Negative 4 is -11, so it would be 11.
this ordered pair is -4, -11. If we are odd, then the number that gives me +11 must be +4. Right, guys?
Yeah.
All right, so D is 4. Okay, that's good. Which means that's 4. All right. Can you do the same thing with A? Because we got the ordered pair 12, 17, but we're odd. So if we're gonna get -17, we must have put in -12. So this right here must be -8. How about here? Look, guys, look. If -1 gives me -8, then what does +1 give me? Positive. Okay, so remember the very first thing I told you today? I said, let's look at these ordered pairs. What does it mean to be odd? What does it mean to be even? That's what you need to know here, right? To do that problem. Mr. Passwater is such a good problem writer. He comes up with such cool stuff. All right. Number 8, the graph of number 8 is an odd function. An odd function. So and our job is to graph the other half of it. So if it's odd, obviously 0, 0 is not changing. What's happening to this guy? If we put in a positive 2, we're gonna have to get out a negative 2. If we put in a negative 4 and get 2, then if we put in a positive 4, we're gonna have to get a negative 2. And if we put in a negative 6 and get 6, then if we put in a positive 6, we're gonna have to get a negative 6. Would you agree with that? Odd means symmetric about the origin. Does that make sense to you? That we just flipped from quadrant 2 into quadrant 4, right across the origin.
Does
Alex?
that mean that it's a reflection of when axis y equals x?
It is. That means it's its own inverse. Okay. All right, what else? Those are all the same. All right, let's go on into worksheet C. Okay, so number 1, we're in worksheet C, number 1. What are all the intervals where f of x is less than 0? F of x is less than 0. Negative 4 to negative 1. And then from 1 to infinity. Would you agree with that? And those should all be open intervals, because we're less than. He says, where does f of x equal 0? Well, that won't be intervals, but f of x equals 0 at negative 4, negative 1, and 1. Right, those are the zeros. Look down at picture 4. Where is picture 4 greater than or equal to 0? Picture 4 greater than or equal to 0. Negative 4 to negative 2. And those would be bracketed. And then we're greater than 0, so from 2 to infinity. Or is that 3? Oh yeah, 3 to infinity, sorry.
Wouldn't it,
My eyes don't work very well.
wouldn't it also be 0?
At 0. So our intervals are going to be from negative 4 to negative 2, bracketed. From 3, bracket, to infinity, parentheses. And then over the side, we're just going to have to say x equals 0. Because it's equal to 0 at that point, too, also. Solve the following inequalities. All right, got a whole bunch of them here. We don't need to do a whole bunch of these. Which one shall we do? Which one looks interesting? 8. 8, actually, if you think about it, you can answer it without actually doing it. Think about that for a second. What do you think the answer to 8 is? Okay, so first of all, it's greater than, not or equal to. So negative 4 and 0 can't be part of the answer because that's where it equals 0, right? But tell me about x plus 4 squared. It's positive. Tell me about negative 7x squared. It's negative. What happens when you multiply something that is always negative times something that is always positive? Always negative. And therefore, will you ever be greater than 0. No, so that problem literally has no solution. Does that make sense to you? You can do a sign chart, draw a number line, do a sign chart, it will give that same answer. But I don't wanna do that one. Pick another one. 11. 11 kinda has some of the same logic, but let's go ahead and do that one. So where would my zeros be on my number line for problem 11? -4, solid dot, 0, and 2. Alright, so I'm going to put in -5. If I put in -5, I'm going to be positive, positive, positive. That does not work for me. If I put in -2, I'm going to be positive, positive, positive. That also isn't going to work. If I put in 1, I'll be negative, positive, positive. That works. And if I put in 3, I'm negative, positive, positive, and that also works. So it looks like my answer is -4 and 0 to infinity. Make sense? Now, it really does make sense in terms of the when you look at the original problem, because what can you tell me about these two factors right here? That's always going to be positive, isn't it? So I'm really looking for where that right there is negative. So where is -x negative? When x is positive, and that's the answer that we got. We got all the positive x's plus the -4 that showed up there. All right, you feel okay about that? Now, there's some on the next page. What do you think you're going to do with something like number 18? That looks a little different. What are you going to do with something like 18? Get it all on the same side, get it set equal to 0, collect like terms, and probably factor it. How about something like 9? And we're doing it without a calculator. So certainly, could I graph these two and figure it out from the picture? Yeah, but we're doing it without a calculator. So 2x squared plus 5x minus 1 is greater than or equal to x squared plus x plus 4. Does that make sense to you? All right, let's start cleaning it up here. So x squared plus 4x minus 5. That look okay? That actually factors, which is really good news. Plus 5 minus 1. So here's my number line. I have solid dots at -5 and 1. And I need to be positive. negative 6, it can be negative, negative, that works. 0 gives me positive, negative, that doesn't work. But 2 gives me positive, positive. So it looked like a really complicated problem, but it came out pretty easy. Negative infinity to 5. And 1 to infinity. Okay? Hang in there, guys. We're just trying to pack as much reviewing as we can. All right, next page, worksheet E. Number 1, f of x is odd. Use the table to find the following. What is f of negative 2? F of negative 2 would be positive 4. F of positive 1 would be negative 5. And if f of x is 11, so in other words, if your table had another row down here and the y value was 11, what would the x value have to be? Negative 5, yeah, that's easy, you got it. We're almost out of time. Okay, let's look at the picture. I'm still on worksheet E. Let's look at the picture for number 4. It says it's even. Part of it's drawn. Part of it's missing. Use the graph to find the following. So I'm on problem number 4 on worksheet 1.5E. And it says find k of negative 5. Well, k of negative 5, negative, that I can't get it off my graph. Would you agree that part of the graph's not there? But the function's even. So what do I know about k of negative 5? It's the same as k of 5. And that one I can get off my graph. What's k of 5? 3. So the answer to the problem is 3. What about k of negative 4? K of 4 is 2, yep. All right, well that's easy enough. All right, let's look at worksheet topic 1.6, end behavior. You know how to do this, right? So, I don't know. Picture 4, the left would be this, and the right would be this, and what would be your answers for picture 4? On the left, it's negative, and on the right it's positive, which is classic behavior for an odd function, right? Odd function with a positive leading coefficient. All right, turn it over on the very back page then, and match up, down there at the bottom of the page, match up the end behaviors, the equations, and the graphs. first limit statements match up with what equation and which graph? Limit statement one is down, down. Would you agree? Using common language, down, down. So that goes with graph A, doesn't it? Isn't A the only one that's down, down? And down, down would have to be a polynomial with what kind of a degree and what kind of a leading coefficient? Even degree and negative coefficient. So that goes with which equation? 3? In equation 3, do C and D matter? Not in this conversation, right? Not in this conversation, obviously they have impact, but not when we're talking about the end behavior. Okay, how about limit statement 2? Limit statement 2 is down, up, which would be graph B, which is what?
Equation 1.
Odd degree, positive coefficient, equation 1. Yep, equation 1. Limit statement 3 is up, down, which is graph C. And that would have to be odd degree, negative coefficient, so that's equation 2. And then 4 is up, up, so that's graph D. And that would be even degree, positive coefficient. So that is equation 4. Does anybody, that little thing right there summarizes a lot. Anybody have a question about one of those? All right, we're good. So tomorrow we'll have just a very brief calculator part where you have to use your calculator to find the maximum, whatever relative maximum, absolute maximum. And then the rest of it will be no calculator. Because basically we did this whole sheet without calculator, right? So this is the kind of stuff.
How did you?
The degree is the highest power.
Alright.
That's what degree is. It's the highest power.
I thought we were adding all.
No, we already talked about that. No.
Enzo.
The degree of a polynomial is its highest exponent.